This is our area of discussion, equations of a straight line. Equations of a straight line. So I want us to have a small discussion concerning this topic of equations of a straight line. And we'll divide this lesson or this topic into two. So the first part, I want us to have a part of introduction and again forming equations. Then the second part is more of application of this topic. So welcome to our class, equations of a straight line. It's good to have some notes. It's good to have somewhere to write. So make sure you're having a place to write so that you will be able to make the most out of this lesson. Right, let us start. The first thing is I'll have a subtopic here that is known as gradient. Gradient. I will define for us what is gradient. And gradient is the ratio of the vertical distance to the horizontal distance. Gradient is the ratio of the vertical distance. So vertical distance to the horizontal distance. The other name for gradient is also called slope. It's also called the slope. So if I have a line that is like this, if I have a line that is like that, if I take the vertical distance is the line from here moving down, and I have the horizontal distance like that. So the line that I want to find the gradient is this one. I'll just take the ratio of the vertical distance. So if the vertical distance is maybe x and the horizontal distance is y, therefore gradient is the ratio of these two. And now that ratio can be written as a fraction. Gradient is equals to the vertical distance all over the horizontal distance. My vertical distance is x, so I'll have x all over the y here. So it's the vertical distance all over the horizontal distance written as a fraction, because a ratio can also be written as a fraction. So simply, that is the gradient of a place. The other name for it is the slope, and this is generally the formula of getting the gradient of a given line. Is the vertical distance all over the horizontal distance. Now, if I have a graph, how do I get the gradient of a point? If I have a graph, how do I get the gradient? So if I'm given a graph, let me open another page here. If I have a graph, gradient on a Cartesian plane, gradient on Cartesian plane, or simply a graph. How do I get gradient when I am looking for gradient on a Cartesian plane? Now, the formula will still be the same, because in a Cartesian plane, I normally have the y-axis and I have the x-axis. This one is x-axis, and this one is the y-axis. The y-axis. So if I have a line that is like that, and I want to find the gradient, I will come and do the same thing. I'll come and do the same thing. So I'll ask myself, what is the horizontal distance and what is the vertical distance? Now, if I take a coordinate here, I pick, maybe I'm having A here and I have B. Let me say the value of X here is maybe X, and the value of X here is also X. But now to differentiate, let me call this one X1 and this one I call it X2. The value of Y here, let me call it Y1, and the value of Y on a straight line, the value of Y here to be Y2. So if I want to get, I know that gradient is equal to the vertical distance all over the horizontal distance, h for horizontal, v for vertical. So the vertical distance, this is the vertical distance. If I want to get this distance, the vertical distance, it will be, I will take, this is the 0 point, I will take this value. The distance from here up to here is y2, and the distance from here up to here, it is y1. So if I want to get the distance between y1 and y2, I will take y2 minus y1. So it will be y2 minus y1. The same case here, if I want to get the horizontal distance, the value here is x2, the value here is x1. So the distance between these two, I'll come and say it is x2 minus x1. Therefore, the gradient in a Cartesian plane is given by the vertical distance, which is y2 minus y1 all over x2 minus x1. That is how we get the gradient on a Cartesian plane. We'll have examples for this, but anytime I get the difference on the y-axis and the difference on x-axis, this is also called the change. These are change in y-axis, these are change on x-axis. So basically, gradient of a point on a Cartesian plane, gradient of a line on a Cartesian plane is a change. I'll use this symbol. This symbol means delta. Delta is a Greek letter delta. So I'll be using this one to represent change, or else I write first what is the meaning of this one. Change in y all over change in x. So that I'll say it will be y2 minus y1 all over x2 minus x1. So that these two, this means if I write change like that all over that, this means it's a change in y-axis all over a change in x-axis. So gradient is given by that change in y-axis all over change in x-axis. This one is a symbol for change. If I write like this, I mean change in y. I write like this, change in x. And this symbol, we call it a Greek letter delta. So we have, this is the formula now that you're going to use. And this is what I want us to really underline here, is what I want us to basically follow so much. Remember, if I want the coordinates of A here, the coordinates of A, coordinates will be x1, y1, and the coordinates of B here will be x2, x1. Right? Let us have some examples here. I want us to have some examples here, and I'll pick some of the lines on a graph. So look at my graph here. I want us to study these graphs together. We have this line. We have A and B, the coordinates of A and B. So we have this line. I want to get the gradient of this one. So let me get the coordinates of A and the coordinates of B. So the coordinates of A, if I write on top here, the coordinates of A will be 0 x-axis, so 0, but y, it is reading 6, so you're having 6. The coordinates of B, I get the value of x is 6, so x is 6, and the value of y, it is 9. The value of y, it's 9. So if I have a line AB, a line passing through points A and B with these coordinates, the gradient will be as follows. The gradient will be as follows. Let me have A. So we are finding gradient. Find gradient of a line passing of a line. Let me write like that. This is visible of a line passing. So I'll come here, find gradient of a line passing through Roman 1. You're having point A, which is 0, 6, and B, which is, let me confirm also, B is 6, 9. This one here, 6, 9. I'll come back here, and I'm having 6, 9. We have 6 and 9. So it's exactly the same as that. So let me label this one as points. This one is x1, y1. This one is x2, y2, like that. So the gradient is given by this formula, change in y all over change in x. So that I have y2 minus y1. So y2 here, which is, let me write y2 minus y1 all over x2 minus x1. So that the gradient will be, if I take y2 is here, which is 9, minus y1, which is here, which is 6, all over x2, which is 6 here. I'll take 6 minus x1, which is 0 there. So I work out this one. 9 minus 6 equals to 3, and 6 minus 0 is 6. Can I simplify? Yes, I can. By 3, by 3, 1, by 3, 2. So the gradient of that line, the slope or the gradient, is 1 all over 2. And that is how I get my answer. I get the answer like that. If I want Roman 2, I pick another line. let me pick another line here to see what I will get. If I pick another line, I go to where I have this another line. I pick line, the second one, this line CD, line CD, and C reads 6 5 6 5 6 5, and the other one 9 10, 6 5 and 9 10. We have 6 9 6 9 and 5 10. I hope I've taken the right reading. Let me go back there. 6 5 and 9 10. Sorry, it is 9 10. So I get 9 10. 9 here. So I will rub this one. That I have 9 10. We have 9 10. So I'll come here and say this one is supposed to be 9 10 and 9 10. I have 9 and 10 there. So this is point C, this one is point D. So we want to find the gradient of a line that is passing through that, right? So I'll do the same thing. Gradient is given by change in y all over change in x. So here I have x1, y1, then is x2, y2. So I'll come here and say this y2 minus y1. So I'll say 10 minus 9 all over 9 minus 6. That my answer 10 minus 9 is 1. All over 9 minus 6 is 3. And I've gotten the gradient of that. So that is how we get the gradient of a line, the gradient of a line. The second part, it is finding the equation of a line. So if I open another page, finding the equation of a line. The second bit is finding the equation of a line. Of course, is a straight line. Now, for this one is a subtopic for that, finding the equation of a line. Now, it's good to note that all the equations are in the form, all the equations of a line, equation of a line, a straight line. Let me write in full. Of a straight line, a straight line are in the form y is equals to mx plus c. This is all the equations of a straight line. They have that form where m and c, they are constants. They are constant in that. So you can have examples. I can have example y is equals to 2x plus 3. That is an equation of a straight line. I can pick another one that is y is equals to negative a third x minus 4. That is equation of a straight line. So we want to learn how do we form this equation. And there are two ways that we can, there are two scenarios that can happen so that I am able to form the equation. One is that when given the 2 points, when given the two points where the line is passing through. So you can have this scenario, you are having 2 points. When given 2 points, then you are told to find the equation of a line. Another scenario is you are given gradient and a point, given gradient and a point. So you can have a scenario whereby you're given 2 points, then they tell you to find the gradient, or else they can give you a gradient, then one of the points, and they tell you to find the gradient, not the equation of a line. But in all these, the steps that I normally follow, the steps, they are just the same. It doesn't matter what you've been given. So the first step of finding the equation of a line is to find gradient. Find gradient, of which is something that we've done, finding gradient of a line. So if you're told to get the equation of a line, find the equation of a line, the first step is to find gradient of a line. Number 2 is use one of the points, and xy to find gradient, gradient. So you use one of the points that you've been given, then and xy to find gradient. And the last step is substitute the two gradients. Substitute the two gradients. You substitute the two gradients, right? So these are the simple steps that I'll be following here. When I want to get the equation of a line, I'll be first of all getting the gradient of that line. Then I use one of the points and xy to find gradient. Then by this time, I'll have the first gradient and I'll have the second gradient. Then the last step will be to substitute the two of them. So these 3 points. Now let us have one scenario here. Let us see. I can have, let me write this one as example 3. Example 3 here. Now, example 3 here. And for this example, I want us to have a scenario whereby you have been given, when you're given the 2 points. So that scenario where you have when given 2 points. So let me first of all write the first part of this one is write equation of a line, equation of a line when given 2 points. So I'll have this. So the first scenario, I've said that this question, you can have a question can come when you've been given 2 points or when you have a gradient and a point. So I want to have an example whereby you have 2 points. So example 3, find the equation of a line passing through. Let me have from an 1. Let me pick one of the lines here. Pick one of the lines, the one that we've not used. Let me pick this A, B, C, D, E, F. Let me pick this one. So 9, 9, 5, 9. This one is the coordinates here. Let me write the coordinates of this one is 9, 5. And the coordinates here it is 14, 2. So 14, 2. So I want to find the equation of this line that is passing through these 2 points. 9, 5, 14, 2. 9, 5, and we have 14, 2. So if I come to my working here, I hope I'll remember what I've, let me, 14, 2, and which other? 9, 5, 14, 2. So we have 9, 5, 9, 5, and 14, 2. This is point E, and this one is F. So a point passing, a line passing through these 2 points. So the first step is to find the gradient, and I know, so step 1. Step 1 is first of all find gradient, and I know that gradient is equals to change in y all over change in x. So this one is x1, y1, this one is x2, y2. So I'll take y2 minus y1, 2 minus 5 all over 14 minus 9, 14 minus 9, 14 minus 9. So I write here minus 9. So 2 minus 5 gives me minus 3. 14 minus 9, this one gives me 5. So I've gotten the gradient here. So that is the first step. Gradient is negative 3 all over 5. The next step, it is to get use one of the points. So I'll come and open a new page here. Step 2, we want to use one of the points. So you have that. Step 2, use one of the points and x, y to find gradient. Now one of the points is 14, 2. Let me pick that one, 14, 2. So I'll use that one and xy to find gradient. I know that gradient is equals to change in y all over change in x. So I'll come here and say this value y minus 2 all over x minus 14. So I have that. That is the farthest I can go because these are unlike terms. Then the last step is step 3, whereby I substitute the first gradient. The first gradient, I got it as negative 3 all over 5. And the second gradient, gradient equals to y minus 2 all over x minus 14. I believe I've copied the right gradient. I've copied the right gradient here so that I have, was it the coordinates 14, 2? Correct, it was 14, 2. So I go ahead and substitute that. So step 3 is substitute. So I say this equals to this one. So let me start with the second one, the second gradient, y minus 2 all over x minus 14. I replace them equals to negative 3 all over 5. Now, this one is a normal sum. Let me cross multiply. This is a normal sum whereby I cross multiply the whole of this one. The whole of this one I multiply by 5, and the whole of this. So the whole of that one I multiply by 5, and the whole of this I multiply by negative 3. And my sum will be like this. 5, I am multiplying by all of this, y minus 2 equals to negative 3, I'm multiplying by the whole of that. So x minus 14 I am multiplying by minus 3. So that if I open the bracket, 5y minus 10 equals to negative 3 multiplied by x is negative 3x. Then negative will turn to be positive. Then 3 multiplied by 14, 3 multiplied by 4, it will be 12. Carry 1, 3 multiplied by 1 is 3 plus 1, 4. So I have that. Let me collect the like terms together. I pick this one, take it to the other side. So I'll have 5y equals to minus 3x plus 42. I add 10. So that my answer will be 5y is equals to minus 3x. I add this 52. 42 plus 10 equals to 52. This has moved to the other side. It changes the sign. It was negative, becomes positive. I can leave my equation that way, it's still correct, or I can remain with y on one side alone, so that I divide here by 5, I divide here by 5, I divide here by 5. My answer will be y is equals to negative 3 all over 5x. I am adding 52 all over 5. So that is now the equation of a line, the equation of that line. So when I am given the 2 points, let me have the last example on this. So let me have example, another example. The other line that is passing through the other 2 points. Let me see. Let me pick a line like this one, ij. The line here, the coordinate of this one is 1 and 1, and the coordinates of this one, it is 9 and 9 and 2. 9 and 2. So 1 1 9 2. Let me see whether I can get the equation of that line. 1 1 9 2. 1 1 and 9 2. So this one is I and this one is j. So I want to find the equation passing through these 2 points. The first step we said is finding gradient. So I'll come and have gradient is equals to change in y all over change in x. So this, I'll begin with this one. This is y2 minus y1. So 2 minus 1 all over 9 minus 1. This is same as 1 all over 8. So I've gotten the gradient there. The second step, I use one of the points. So I'll use one of the points, any. I can either use this one or this one. So I'll use 1 1 and x y. I want to find the gradient using this. Remember, I'm using a coordinate that is having some small values just to minimize errors when dealing with huge numbers. So I just use the one that is very simple, right? So gradient again for this one will be change in y all over change in x. So I take y minus 1 all over x minus 1, right? And then the last step is to substitute. You say this one equals to this value, this gradient equals to this gradient. So I'll come and say y minus 1 all over x minus 1 is equals to 1 all over 8. Then I cross multiply the whole of this one, y minus 1 multiplied by 8 equals to x minus 1 multiplied by 1. Y minus 1, I am multiplying by 8 equals to 1 x minus 1, like that. If I open this bracket, this will be 8y minus 8 equals to x minus 1. Then I put the like terms together. If I take this one to the other side, it will be addition. So I'll have 8y equals to x minus 1 plus, because now this one becomes addition, minus 1 plus 8 becomes plus 7. So we have that. I can choose to remain with y on one side, although you can leave your equation this way, or I can leave y on one side. I divide across by y. So here I'll say 8y is equals to x plus 7. This will be, I divide here by 8, I divide here by 8, I divide here by 8. The answer will be y is equals to 1 all over 8x. I add 7 all over 8. 8x all over 8 is just the same as an eighth of x. An eighth of x. So you can leave your answer that way, right? I believe that is clear, right? Now, the second one is when I am given gradient and one of the point. So the last one is when given. When given, let me have this one. The second scenario, when given gradient and one of the points, Now, when I am given gradient and one of the points, my work has been made easier. My work has been really made easier because the steps are still the same. The steps are still the same. The first step is, first of all, find the gradient. The second step is use one of the points. And x, y. Then the last step is used to substitute the two gradients. So let me have an example here. Let me have an example that we have here. For example, I want to find the equation of a line, equation of a line passing through -2, 7, and has a gradient of maybe a half, a gradient of a half. So I have one of the points -2, 7, and I've been given the gradient. Gradient is equals to a half. Now, this means the first one has been done for me. Already they have given me the gradient. So I'll directly go to the second step. And here now, I don't have to select 2 points. I will only use the point that I have here. So I will say use -2, 7 and x, y to find gradient. So I'll have my gradient will be changed in y all over change in x. So that I'll say y minus 7 all over x minus 2. Now I equate to that because already they have given me the gradient, so there is no need for me looking for gradient again. So I'll just go to step 2, whereby I use the point that I've been given and xy to find the gradient, and this is what I will have. All right, then I come and substitute. So I'll take this one is equals to this. So I'll have y minus 7 all over negative turns to be positive. So x plus 2 is equals to the gradient is 1 all over 2. Then I go ahead and cross multiply. So I'll take that, multiply by that is equals to that, multiply by that. So that I have y minus 7. I am multiplying all these by 2 equals to 1 x plus 2. I am multiplying by 1. If I open the bracket, it will be 2y minus 14 equals to x plus 2, like that. Then we put the like terms together. 2y, if this one I take to the other side, it will be positive. So I'll say 2y equals to x. This, when you go to the other side, plus 2 plus 14 gives me plus 16. So, and that is the equation of a line. I can choose to remain with y on one side. Y equals to x all over 2 plus 8, because 16 divided by 2 is equals to 8. And that is how you get the equation of that line. I hope up to that it's clear. When you're given one of the points, when you're given one of the points and the gradient. Let me have one last example. A line that is passing through a half and 6, and the gradient you've been given is a value like negative 3, like that. So I have a line passing through this, and the gradient is that. Now I will follow the same steps. The first one has been done for me, so I'll come and say that gradient already is negative 3 all over, or negative 3. I can have like that, negative 3. Then the second one, I use one of the points of which I've been given the only point, so I'll have a half and 6. Use and x, y to find the gradient. Let me see what I will have here, right? So if I use that point, this is what I will have, right? So I will have gradient is equals to change in y all over change in x. And I have one of the points is, let me write the points here down, a half, 6, and the gradient, and I'm using together with x and y. So I'll say y minus 6 all over x minus a half, x minus a half. Then I go ahead and substitute. So the last step is substitute. I will say y minus 6 all over x minus a half. All this is equals to negative 3, like that. Then I cross multiply. Any number without a denominator is 1. So I will say this multiplied by that is equals to that by that. If the denominator is not indicated, just know it is 1. So we cross multiply. Y minus 6, I am multiplying by 1 equals to negative 3. I am multiplying by x minus a half, like that. Then you open the bracket. This will be y minus 6 equals to negative 3x. Then negative turns to be positive, so plus 3 all over 2, because 3 multiplied by half is 3 all over 2. Then these one are like terms. I take this one to the other side. It will turn to be positive. that my y will be the y in this case will be, if I open that bracket, it will be negative 3x plus 3 all over 2. I am adding 6. Let me add these two. Let me add them to see what I'll get. I'm having 3 all over 2. I'm adding 6 all over 1. The LCM, it is 2. So 2 divided by 2, 1 multiplied by 3, 3 plus 2 divided by 1 is 2 multiplied by 6, that is 12. So my answer is 15 all over 2. So the final answer here will be y is equals to negative 3 x plus 15 all over 2. And that is how we get the equations of a straight line. Equations of a straight line. I believe you've gotten something out of this, and it is always good to do more exercise on this so that you are able to practice and even to understand better. Now, I would wish to give some work so that you can get your feedback here. Let me have some examples in each. So I want to give, I want you to attempt this one. Example. I want you to attempt this one. I want you to find the equation. Find the equation of a line passing through Roman 1, passing through, let me pick some points here, passing through 3 and 10, and the gradient here, gradient is 3 all over 4. That is Roman 1. The second one, it is negative 2 and a half, and the gradient, so the gradient here is a value like gradient, a value like 7. So you tell me, feel free to write it down, and also you can give your answer in the comment. So we have this one as an exercise just to jog your mind. So this one is when you're given a 1 point and the gradient. Also good. You can also check this one. Could you also try to get the gradient of these lines? We have this line. We have line 1. This one. This line. This. Find the equation, not gradient, of this line together with this one and together with that. Those are 3 and these are 4. So gradient of line 1, line 2, line 3, line 4. You can stop the video so that you get the coordinates of this one and you're able to get the equation of that line. So get me the equation of this one, equation of line 1, equation of line 2, equation of line 3, equation of line 4. So I want find, this is the instruction, find the equation of line 1, 2, 3, and line 4. So we have them here, line 1, line 2, line 3, line 4. I'll be glad to see what is your answer in all this. Thank you so much. Have a wonderful time.